Today we're going to talk about the Defender 88PH Plus Windows and a couple things beyond just the product itself, of course. A little bit about me. So my name is Mike Cairns, and I am the business development manager at Innotech Windows and Doors, a certified passive house tradesperson. I built and live in a passive house, and obviously work for Innotech Windows and Doors. Innotech has been around for a little while here, with a concentration on performance. We've been building products that are appropriate for high-level performance projects, including Passive House certified, basically since we started. So we've got a long history in the Passive House world. We manufacture windows and doors for custom homes and low to high-rise multifamily housing projects. So that includes affordable and senior housing, hotels, schools, office buildings. The majority of the projects that we supply have a clearly defined performance target, such as acoustic requirements, air tightness, water resistance, or thermal. Our first certified passive house project was completed in 2012. The Bagley Nature Center at the University of Minnesota is a 1,500 square foot classroom that achieved a 0.47 ACH 50, which is impressive enough by today's standards, and a decade ago, it was relatively unheard of in North America. As you can see, the project achieved net zero passive house certification and LEED Platinum. In the interim, over the last few years, we have seen a tremendous growth in passive house projects, both as a result of code requirements and hardworking associations such as Passive House Alberta, Passive House Canada, and FIAS that are continually advocating for better built houses and buildings. Innotech is currently involved in over a dozen multifamily projects that are targeting passive house certification. Some of these completed in the last year or so, while others just received their building permits. And these are projects that are located in BC, Alberta, Ontario, and in the US, primarily in the Pacific Northwest region. The Peak is one of the many multifamily projects in Vancouver, BC. The BC Energy Step Code and City of Vancouver building bylaws are both contributing to the rise of passive house projects in the city and the province. Our products are also used in projects targeting FIAS certification. The Parkview at Terwilliger Plaza is the largest independent living passive house project in the US and the largest passive house project in the Western US. In the last 2 decades, our products have been consistently specified for high performance projects. In addition to multifamily developments, we manufacture windows and doors for high performance custom homes, which historically has accounted for about 70% of our overall sales and manufacturing volume. From R2000 to Passive House, we have had the opportunity to support a lot of progressive building professionals in the last 2 decades. Today, we're going to talk about windows for Passive House projects. Passive House Institute component certification is the next level in performance for fenestration manufacturers. But it is important to remember that it isn't the only measurable performance factor. So let's take a look at why our products are consistently specified for high performance projects. The whole is greater than the sum of its parts. Why is that pertinent? A window is a system, not just a random assembly of objects or a single set of performance data. And that's how we look at performance. It's a system. This is especially true in the world of Passive House, where there's a very heavy emphasis on thermal performance or U values. And while obviously extremely important, those wouldn't be of much value if the window leaks air or water, or if the window doesn't have the structural integrity that it needs. Or even if the operating hardware breaks down within a few years and you can no longer easily open your window. Whether you're designing or building a passive house or any other type of high performance standard, what you need is a window system that delivers reliable performance. So reliable performance, how is that achieved? High quality components that are engineered to work together, expertise in assembling those high quality components, and a robust testing program. So laboratory, third-party testing, in-house testing at our manufacturing facility, on-site testing at various projects in North America, and real-life testing, so product performance over 20 years, 20 plus years of installations, and reliable performance. What do we mean by that? When we look at performance in a window or door, there are 6 key factors that we can measure. When aiming to achieve the highest level of building performance, such as Passive House certification, you want to ensure that your windows and doors meet each of these factors. Airtightness. To meet the requirements of Passive House Institute certification, the building needs to achieve a 0.6 ACH 50. It's fair to say that this is difficult to achieve without airtight windows. With FIAS, their recommendation is that facade components should have an airtightness rating of no more than 0.05 CFM per square foot. PHI recommends 0.03 CFM per square foot, so slightly increased performance requirement from PHI. And that's for larger buildings, and you would want, obviously, less air transmission for smaller buildings. And just in general, an energy efficient window will be an airtight one. It won't let unconditioned air into your home, and it won't let your conditioned air out of the home. And with wall assemblies continually pushing for greater and greater air tightness, it only makes sense that windows and doors should be as airtight as possible. In Canada, the North American Fenestration Standard, or NAFS, requires manufacturers to test for both air in and air exfiltration. The highest standard for an operable is C3, which is a requirement of 0.1 CFM per square foot. For fixed windows, it's a little tougher at 0.04. So you can see that the typical North American window standard, if you just meet that minimum requirement, you're actually not quite at the facade component recommendation for Passive House International Standard. Here's an example of a project that achieved a superior whole building airtightness result. And it's worth mentioning that this is not a Passive House project. The Maitland Street Village is a recently completed affordable housing project on Vancouver Island in BC. This project was designed to achieve the highest step of the BC Energy Step Code for Part 3 buildings. So with a combination of great design, great material selection, and great trades, it achieved a 0.34 ACH 75 on its final blower door test. To me, this building is an excellent example that high performance is achievable for all types of projects, including affordable housing, multifamily buildings. It's a well-designed building executed with great skill and attention to detail, and the result is a building that will keep many people safe, secure, and comfortable with minimal energy use for decades to come. The second measurable performance factor is water resistance. An airtight window is a water-resistant window. Keeping water out of your building envelope is critical to the long-term durability of the project and to avoid health concerns as a result of moisture and mold. We regularly test products for water performance, both in-house with our custom-built water testing chamber and on-site. Our products achieve 720 pascals, which would be a B7, for windows and most doors. This is water testing done by RDH at the Holden of Pearl project in Portland, a 16-story high-rise. This is a short video. It was actually created by Prosoco. So they're one of the leading brands of liquid flashing membranes. The storm in a box that you will see was built to showcase the importance of appropriate material selection, construction sequencing, and design details in the construction of energy efficient building envelopes. It simulates a Category 5 hurricane with winds in excess of 155 miles per hour, and it tests the air leakage, water leakage, and durability of materials in the building envelope. Obviously, the speed is increased in the video here. So this first window here, you can see the initial leakage. You can see interface failures at multiple points. They're only up to 45 mile per hour winds, and then just complete and utter failure of every point in the window. So obviously not going to be that spectacular for the building or its occupants. This is the sort of damage that we see as a result. We're very familiar with this in the Vancouver region, having gone through the leaky condo crisis. So in this second test, this is an Innotech window. that has been installed in a properly detailed window installation opening. So you will see a nice air and weather barrier using the Kosoko fluid film product. So cranking up the test, they're already past where the first window failed, and now they're cranking it up pretty quickly. Past category 1, now they're up to category 2 hurricane, 150 kilometer per hour winds already. No issues whatsoever. Category 4 at 130 miles per hour, and then category 5 hurricane, and they keep dialing up for a period of time. It's not a problem for a window to achieve high levels of water tightness if it's been a properly designed and built system. So thermal performance. Now this is one that passive house professionals are most likely the most familiar with, and the passive house standard places a lot of emphasis on this. With windows, it does get a bit complicated. The various components of the window are evaluated separately, brought together in the PHPP. We have the UF, which is each side, the head and sill, including a small portion of glass as well. And then this is applied as a measure of total frame area. The center of glass value is determined and applied across the area of glass. Then the very edge of the glass where it meets the frame gives us a linear value. Altogether, this is the UW, and the total heat loss of the window can be calculated easily from there. As important is the installation detail. So this is another linear value based on the performance of the window wall interface point. Poorly detailed, this could be the most significant thermal bridge on a multifamily project, and it can also lead to sometimes very serious condensation and comfort issues. One of the sometimes overlooked details is that each component is calculated individually. So meaning every single piece that goes into the window or door has a specific value. In the actual product you receive, it's important to determine that no additional structure is required, or that you have been given correct data on the product that will be used in your project. It has occurred in past projects that delivered goods do not match the certificate. This can be a frustration for the project team at the end of the project and affects the real performance of the window. So the UBC Evolve project team at ZGF Architects up here, or ZGF Architects across the border, so they were very diligent in their review. In some of the windows, additional reinforcement was required for structure, but just throwing some steel in there would have caused potential issues. Luckily, we were already underway with some R&D for just this purpose, and we were able to provide alternate structural reinforcement that met their project needs for both the structure and the specific thermal values of the components. The passive house standard places a lot of emphasis on comfort, mostly within the constructs of thermal performance. But as we know, comfort is so much more, including limiting or eliminating unwanted outside noise. There's a bit of a common misconception that highly insulated buildings will automatically have great acoustical resistance, but thermal performance does not equate to acoustic performance. It's recommended to conduct an acoustical analysis independent of thermal performance analysis. Sound transmission class, STC, and outside to inside transmission class, OITC, are two different measures of sound, and they're not interchangeable. OITC is a more reliable rating for facade components because it actually measures the wider band of frequencies, including very low noises that are commonly emitted by cars, trucks, aircrafts, that would be basically ignored by STC, because the STC is intended for the transmission of common sounds within an envelope, so conversation level noise. The 2020 Apartments in Portland, Oregon is a 7-story steel and concrete multifamily development with 162 units. This project had 2 core performance targets: to minimize energy consumption, to reduce the ongoing operating costs for the building owner, and to maximize occupant well-being by reducing unwanted outside noise. The 2020 is right next to a major transportation, including freight rail lines, the TriMet Max light rail line, and the I-84 expressway. While convenient for residents, the building's location meant that it required intentional design and build strategies and materials to effectively reduce noise transmission. The well-being of a home or office space is heavily impacted by unwanted sound. The result is an approximate OITC of 29 decibels and STC of 35 decibels for the east, west, and north elevations, and an OITC of 31 decibels, STC 39, for the south elevation, which surpassed the specified minimum requirements. So a little known fact, dual action windows have a gateway size under the NAS testing regimen that's 20% larger than all other window types for the same test. Is this fair? Not really, but dual action windows have to perform better on the same test as does a casement or a sliding window. It's much easier to achieve any kind of performance except thermal on a smaller window, and that's especially true for structural performance. So it may not be fair, but it indicates that dual action windows are generally considered the better performing window. Mixed in with this is durability over time. Commercial window testing requirements include cycle testing. So they run through thousands of cycles of operation to ensure the durability of the product and hardware that residential and light commercial windows are not subjected to. And the sixth measurable performance factor is environmental transparency. In the past few slides, I've mainly focused on how a high performance window can impact a building's energy efficiency, which is increasingly now referred to as operational carbon. But what about a building or product's embodied carbon? Last year, City of Vancouver voted in favor of adopting changes to the VBBL that will require all new buildings to report and limit their embodied carbon starting this year. COV is recognized throughout Canada and the US as a leader in establishing aggressive building code requirements to significantly decrease greenhouse gas emissions. We anticipate that many more building codes will adopt similar restrictions and reporting of both operational and embodied carbon in buildings. So, Innotech is in the process of developing our life cycle assessments, environmental product declarations, and health product declarations. In 2001, Innotech made a commitment to only manufacture high-performance fenestration systems, regardless of the mass market demands. All of the windows we manufacture are dual-action or tilt-turn windows. Tilt and turn windows are an engineered system that are designed to achieve superior performance in air, water, thermal, acoustic, and structural values. Let's take an in-depth look at tilt and turn windows. In addition to performance, tilt-turn windows provide effective and safe ventilation in the tilt position. Now, taking advantage of the stack effect, warm air rises and increases pressure. If you have an opening that's higher up in a space, the higher pressure, warmer air will force its way out of the opening. This simultaneously draws air in at the lowest available opening, which is likely to be cooler air. So in a tilt-turn window, because the opening reduces towards the bottom, you're drawing in the air, it increases in velocity, and you end up creating a natural convection current inside of the rooms. This gives you a greater amount of effective ventilation and increases the potential for cooling that you will get from the air moving at a higher velocity along surfaces. Tilt and turn windows also have multi-point locking hardware. The hardware affects performance, air, water, sound, security, and durability. So the long-term performance of the window relies on the hardware maintaining an effective seal. Remember, you want to have your window to have reliable performance over many, many years. The operating hardware needs to be strong enough to smoothly open and close your window, those very heavy IGUs that we have to deal with, and the operating hardware has to be engineered to withstand that weight year after year. So the right hardware is critical. Innotech manufactures a wide range of products, including windows, swing doors, and sliding doors. The Defender window series includes 3 windows. The Defender 76TS on the far left, it's our legacy high-performance window. It's available with double and triple glazing and is regularly specified for high-performance projects, including FIAS and PHI certified. The Defender 88PH Plus Pro system is our newest window system. It's available in 2 performance configurations, the Pro, which is a PHI cool temperate certified, and the XI, which is a PHI cold climate certified component. And we'll take a little closer look at the 88 system here. It builds on over 20 years of high performance fenestration manufacturing experience, and it reaches a North American industry milestone. It is the first Passive House Institute cold climate certified window system manufactured in North America. And it's the first UPVC cold climate certified window system manufactured in the world. Digging into the components and assembly details of the Defender 88PH Plus that result in the reliable performance we all want in a high-performance fenestration system. First, we begin with durable hybrid frames. These are UPVC profiles with thick outer walls, large frames. This improves our glazing edge and installation U values. It's easier to over-insulate, and it makes for simpler and better air barrier tie-ins. And of course, it's a multi-chamber design. The frames and sashes are strategically insulated and reinforced. BASF Neopore is a graphite polystyrene insulation. There's two types in our windows. So there's a high density structural foam and a low density, higher insulating foam. I'll just take one quick moment here to ask Kim, do we have any questions we need to go over?
So the window in the gallery on your website, do not show those screws around the sill of the window. How is a sill built to hide those screws around the windowsill? Do you have a video showing step-by-step installation? That might come later, maybe.
So the gallery do not show the screws around the windowsill.
I think she means the metal hardware that is used for installation on the sides of the windows.
Okay.
How that comes into the inside of the building.
Sure.
And how that's installed.
Yeah, well, we do have step-by-step instructions, and I've actually done a couple of videos that we have on our YouTube channel that show the installation and how it's handled. And so that the installation is done with a strap anchor that runs to the interior side. And if anybody's curious about specific details that would be used, they can feel free to drop me a line, and we can go over a couple different ways that maybe different projects have overcome maybe some of the typical air and water barrier tie-ins that you would have through your fastening points.
I think Jessica's given a link to a video for installation as well on the
Awesome.
in the chat. Okay. And can tilt and turn windows include bug screens? And I think the answer is yes, right?
Yes, they do include bug screens.
Okay.
Or ours
Okay.
do.
Yeah. Okay, Mike, you can go ahead.
Perfect. Thanks. Strong and stable sashes. So a known weak point in windows is the sash. So the operable sash has to be built in such a way that it can withstand the weight of the insulated glass unit, as well as the typical environmental forces that are applied to it. When we have wide IGUs with 3 thick panes of glass, the stress on the sashes is even greater. They're very heavy IGUs. Non-reinforced sashes can warp either due to the weight of the IGU or due to the natural thermal expansion and contraction of the material of the sash. But here's the kicker. To meet the performance standards of cool temperate or cold climate component certification, we have to reduce the thermal bridging, which often eliminates the most efficient reinforcement materials as an option. But BASF UltraDur, it's an innovative new material made of 55% glass fiber with 45% PBT and PET. So it's an extruded PBT fiberglass. This gives it high structural properties and dimensional stability, high melting point. It's very lightweight in comparison. So it's less energy to transport, reduces the overall weight of the sash, and it's fully recyclable and reusable. All of our windows, including the Defender 88 PH Plus system, are assembled with fusion welded frame and sash corners. So this avoids some of the common weak points that may occur in windows and doors that use mechanical fastening of some kind or rely on sealants to create your air and water seal at the corners. Fusion welded corner is 100% air and water tight. And our fusion welding includes both the frame and the actual seals themselves. The gaskets are fusion welded. So they maintain that air and water tightness for the lifespan of the product. For our insulated glass units, for the Passive House products, we follow the European glazing conventions, which is a much deeper unit than what the North American fenestration system or standard would typically recommend, but the values do match up with the local climates extremely effectively. And of course, the Passive House system is designed to accommodate the specific climate of the project in question. Regardless of the glazing system that you use, or the evaluation system that you use for your glazing, the weakest point of your unit is going to be the glazing edge. So to combat that weak point, we use the Super Spacer Premium, which is an excellent spacer system. It gives our windows an edge value typically about 0.023 watts per meter Kelvin. Some of the units are a little bit lower than that, but it is an Arctic rated spacer and it functions very, very well. This is the performance summary for the 88pH Plus system, fixed windows. Some of the NFRC simulations may not be complete for the XI, but they will show an improved performance because they are more highly insulated. We are huge fans of seeing the additional assurance that comes from the NAS testing system. It covers air tightness, water resistance, and design pressure to give you a performance class and grade. So you can see legitimate test results for an actual tested product. So it's nice to be able to say, oh, we have an actual air tightness of almost 0 or 0 transmission. That's handy. For water, everything that we build is tested to the Canadian max 15 PSF. So that's about 127 kilometer per hour wind equivalent. Design pressure is the wind loading, the structural resistance. 60 PSF is approximately 250 kilometer per hour winds. In real terms, over 3,000 pounds of load on that tested size before hitting the deflection limitation, L over 175. So that's about 5/8 of an inch of total deflection on the window. The UW, of course, is based on the reference glazing, the 0.70 watt reference panel. But you can see that the frame values between the two systems do vary a fair bit, not overly significantly. If you're talking about a 0.65 versus a 0.660 on the operable, but 0.54, obviously a significant difference in the risk of condensation when you're talking about cold climate temperatures. And the total UW starts to vary. You can't squeeze as much performance out of the unit because you're relying on the same glass basically. So you really have to improve the performance of the frame to improve the performance of the window. This is the performance sheet for the 88 operable windows. So very, very similar. One interesting thing to note, if you take a look at the air tightness on here, if I go back to the previous slide for the fixed window, the air tightness actually improves for the operable window. So part of this has to do with the continuous hardware that runs around the sash and pulling it tight and maintaining consistent contact against the seals. And the additional hardware improves the strength of the frame a little bit. The additional profile also adds some strength. So you actually get less movement in the window under those air tests. And so the seals against the window actually maintain their pressure more effectively. So that's kind of the opposite of most window systems when you switch to an operable. Design considerations. Performance is very much impacted by things outside of a manufacturer's control. How the fenestration is designed, where and how it is installed in a building, this all impacts performance. As a designer or a builder, how do you ensure that you get the most out of your windows and doors? We've narrowed it down to 5 key design considerations. Larger is better. Combine your openings together. Keep the design simple. Orient carefully, shade effectively. And don't forget about the installation. So It's a really good practice to know the size limitations of your manufacturer of choice and work within them. There's an optimal size for a window. The optimal size will vary for each manufacturer, but as a general rule, bigger is better. Now, I didn't say that the biggest possible window is better, only that bigger is better. So much as you already deal with window to wall ratios, think of windows in terms of glass to frame ratio. Too much frame compared to the amount of glass will lower the overall performance of the window, even for Passive House Institute certified windows. In North America, homes and buildings have much more fixed windows than operable ones, and the operable windows are often very small. This is because operable windows have historically performed much worse than fixed windows. But while the technology has improved, we're often still designing to accommodate low-performing operable windows. And it no longer makes sense to design with very few and very small operable windows. Effective natural ventilation is an important factor for passive house projects. Innotech manufactures dual action or tilt-turn windows. And for everyday ventilation, the windows are tilted. To maximize ventilation, in other words, for the largest volume of air to flow through the windows, wider windows are better than narrow ones. Limit the number of wall penetrations by combining openings into single larger openings. Not only will this reduce your risk of air loss and thermal bridging, but it will also be less expensive. The price per square foot for small windows is much higher than for larger windows. You'll also be saving on your framing, installation, air sealing, and interior-exterior finishing details. So this is actually a very common design that we see. This is about a 7x8 window. The operable sashes are at the bottom. These windows tend to have very poor ventilation. They're difficult to operate. You have to bend down to crank open the window. The operable sash is small. The horizontal mullion can interfere with seated sight lines. And so we've drawn a couple of different configurations here to see what happens. Option 2 actually saves about 25%. Option 3 is about the same. The handle in the second option is almost 6 feet off the ground. So it's workable, but it's not ideal. Excellent ventilation at the top. Option 3 is about the same, but it drops the handle height by about 2 feet and brings it into ADA compliance. The ventilation height is still above head height, so it's very effective. And option 4, I would think, is pretty self-explanatory. This is the River West Apartments in Vancouver, Washington. These windows hit that optimized for use, that third design concept very well. They have nice sized operators, convenient hardware placement, large fixed panes. The fixed transom at the top not only lowers the head for hardware placement, but also provides a simplified mounting area for window coverings. While not the most effective possible window design in thermal terms, this is the most effective overall design in holistic terms for this project, and it does maximize the benefits of the dual action window system. Analyzing the details of another window design that we have seen not just once, and illustrating the general concepts of how we improve by simplifying. As we move from the original design on the far left to the optimal design on the right, we drop the cost by about 25%. We reduce the mullion bridging by 33%. We have increased sash bridging, but also the ventilation rate, reduced the glazing edge by 40%, increased the glass area by almost 20%, and eliminated visual clutter for occupants, whether standing or sitting. And it makes our production much happier to build the simplified window. Now, one thing worth looking at is that the potential for air ingress is less on the optimal design versus the original. So on the fourth window here, it has a joint. So everywhere that you have a joint or seam, you have a potential for air movement. So you have a joint from frame to glass, from the sash to the glass, and from the frame to the sash, totaling about 51 feet. On window 1, it has the frame to sash seal, the sash to glass seal, And all of these frame to glass seals here, totaling 71 feet. So that's a 40% increase of joints, and obviously a significantly heightened potential for air ingress or egress. Now, another thing to look at is in the original design, this operable window is very small. It gives very poor ventilation. The horizontal mullions interfere with sight lines. The small glass panes decrease overall performance. All of these mullions add cost. There's more cleaning, there's more complicated maintenance in the future if there's a failure, and every mullion increases the thermal transfer, sometimes significantly if additional reinforcement is required. In the optimal design, you've got larger windows, much improved glass area and ratio, offering significantly better thermal performance. Vertical mullions make buildings look taller. You have less interrupted sight lines, and you're raising the height of your ventilation space. So you're improving the potential for air movement. Now, active or passive shading is a strategy question. The perfect orientation of the building to meet the passive house goals may not be possible or sensible based on its surroundings. Other buildings, lot constraints, building code limitations, natural vegetation views, or aesthetic preferences. Understand the constraints at the onset of design so you can plan effectively. There's a bunch of different, fabrics and materials and things available for shading. The UBC Evolve used a mix of passive and active shading. On the left is the architectural rendering. On the right is the actual building. They ended up remarkably similar, which is amazing. The architects effectively used the mature trees to act as shading during the hottest months of the year, which is both brilliant and beautiful. So the combination of vegetation and aluminum shroud provides passive shading. But the Evolve project also used the aluminum shrouds to provide passive shading and active shading strategy. So they installed movable shading panels on the outside of the windows that allows the occupants to exercise more control over the sun's heating effect on indoor air. The Peak project in Vancouver used a different active shading strategy by installing exterior solar shades. These shades are manufactured by MHZ North America and are motor operated with solar sensors. There's actually a whole raft of sensors based on temperatures inside, outside, wind, a bunch of things like that. And there's a whole bunch of different fabrics that can control your heat gain, privacy, and aesthetics. So the picture on the left is no shade. The center one is with the shade down from the interior. And then the third is the exterior view with the shade down. And last but not least is installation. So to achieve your desired performance target, you need a well thought out and well communicated strategy for barrier layer and layer connections. You need to intentionally select the most suitable building materials and install all building materials, including the window, as per the manufacturer's instructions. So that is the end of the preformed presentation here. So I'm hoping that there are more questions.
Thank you, Mike. I do have questions for you.
Okay.
Okay. So, so this one's from Zach, and he said that Intertech windows tend to be on the higher end of the price range due to the energy efficient design. And what's the rough payback period for the energy savings to offset the higher initial cost? That might take you more than 10 minutes to answer.
Well, it's one of those interesting things that we don't quantify what the cost payback is on the energy savings in those direct terms. There's so much more to it in terms of the return that you get on that investment. Most of them have to do with the comfort of the occupants, the durability of the product, the actual performance, the elimination of the risk of condensation and the cold spots. So, trying to figure out how to quantify that in dollars and cents terms and how quickly it occurs is difficult, and it's going to change from place to place anyway. A window replacement in Vancouver here, where the climate's relatively mild, might be something like a 20-year return, whereas if you're in Edmonton or Prince George, maybe you're just talking about 4 or 5 years. Like I have no idea, to be honest.
I'm going to just pipe up just a quick add to that. It really depends on the installation and the whole building as a whole. So having better windows might mean that you can use a little less insulation, which saves you money in the short term or right at the beginning. So so I don't think it's that easy to just say there's a payback period for any energy efficiency products. You have to look at the entire project as a whole.
Awesome. Yeah. Great answer.
Okay, so I'm going to go through some other questions here, so we have some time. So one of the questions is, how does Intertech approach installation, and does Intertech have partners for installation? And excuse me.
Yeah, so our approach to installation varies depending on the region. So we do have a number of partners that we work with. So we do provide installation in some regions, and we have partners that provide installation in other regions.
Are you servicing PEI?
No,
Okay.
not currently.
Okay. Somebody saw the 20th anniversary discussion, and in it you stated that Intertech was going to be making an aluminum clad vinyl window. If will that be available if it's not already available? And I think it is, isn't it?
It is. So the exterior aluminum cladding is available, and we have actually used it on a couple of projects already, mainly in storefront areas. There's a certain perception of durability that the material itself will have in that ground level application that drastically increases its desirability for storefront applications.
Okay. A percentage spread between the 88s and the 76 systems.
I'm
and cost,
not
of course.
entirely sure. I'd say probably somewhere in the 25% range is a realistic expectation.
And again, that has to do with the size and shapes of windows, and it's an overall package.
Yeah, it can get really difficult to figure out, especially when you're talking different systems. Oftentimes you're talking about maybe different design goals as you're shifting the performance goals of the building. So then you might be altering the base window designs to suit a new building thermal model. So
it's a give and take for sure.
Yeah.
Learning some more details on maximizing window and door installation. So I'm not sure, I think you may have addressed most of that in your presentation.
Mhm.
But the details for installation, are they available as well on your website?
We do have some details available for installation, and this slide here shows this is a mock-up and assembly that we put together with some help from a partner of ours on this. And I guess maybe I'll defer to Jessica if she wants to discuss who that is and how they get into contact with them and that sort of thing. I think would be great. But there are a couple of companies out there, obviously, that can help people with the designs and performance strategies of their windows. Our concentration as a manufacturer is on the performance of the window itself, and we try to do our best to assist people in coming up with some strategies that may assist them in improving the performance of the windows and the assembly as a whole. We don't design the installations ourselves, but we would certainly work with you on that.
Jessica, did you have anything to add to that?
I did put the link to some more info on 3D modeling and installation details in the chat. So if anyone wants to take a look, it's in our blog on our website. So there's more info there that everyone can take a peek at if you want to get into the installation weeds.
Okay, so there's a question about the lifespan of the windows and doors, Innotech windows and doors. What's the expected lifespan of the frames?
That's a really good question, because we really haven't reached it in practice yet. We use profiles manufactured in Germany by Kummerling, and the Kummerling profile system has been in active use for many decades. There are some building examples in Germany from the early 60s, and those windows, the original windows, are still in active use. We have seen products locally here from the early 80s in R2000 homes. So the realistic lifespan of the products, I think part of the conversation has to be how long the product is going to meet the original designed expectations. So it's not just, is that frame going to physically be in the wall and kind of staying together? It's, does it actually stay airtight and watertight? Does the hardware still function? You know, is everything actually working the way that it's supposed to? And the expectation for our product is more than 40 years without question, and it may be beyond 60 years, as has been demonstrated in use. And at that point, you know, you're probably talking about hardware becoming obsolete, glazing for sure. There will have been some kind of advancements that will have made it obsolete in the meantime. So you're probably at the point there, when you're talking 40, 60 years, where the window may still be functioning perfectly well, but there's probably going to be parts of it that need to be upgraded to meet whatever those future or then current expectations. But the base window itself will still be performing for many, many decades without question.
So one of the questions was, would you ever install these windows in a retrofit?
Absolutely. It's been done many times in the past. There typically are some more considerations where, you know, you're not going to do that really unfortunate sort of stucco flange, like, oh, we'll just, you know, rip out the old frame and glue this one to the wall in front of it. But I don't think anybody that's involved in building science is interested in doing that anyway. So
Natalia has asked which textures and colors are available inside and out for the pH cold climate windows.
There's a pretty reasonable range. We have we use the base product is a white UPVC finish that's extremely durable. To apply colors to it, we've got a palette of about a dozen colors. They're in solid colors and wood grains, and they are actually a PMMA plexiglass foil that's applied with heat and acrylic adhesive. So it's a UV reflective and a highly resilient material that allows us to apply color, and we don't have to worry about it fading, chipping, peeling, cracking, any of those typical, you know, painted or powder coat finished issues that you might see. And it's also recyclable, the same as the UPVC is.
A question about the front entry door systems. Are wood doors available, or are they all just UPVC?
They are all UPVC. So we do have some wood grain finishes, and depending on the style goals that you have, you know, we may be able to create a door. They're all custom made. So, you know, the design is sometimes a little bit up in the air, you know, with what you can envision and what we may be able to match. But yeah, you know, we can typically do something that would suit many different architectural modes.
I missed one here from Lisa. Does your website contain information for energy advisors in modeling the windows on a house to calculate the energy savings? Do you have partners in energy modeling? I guess that might be. Or
well, we do in-house Flixo modeling for our products, so we can provide the specific component values. We can provide the Flixo models to you as well. And I'm not sure beyond that in terms of like the energy savings for a house. I think that's not really something that I know too much about.
Yeah, so I think my answer to that question would be to engage a certified energy analyst and or a passive house consultant, and the whole house would have to be modeled in order to determine whether one window or another was better or makes sense in the build. It's not as simple. It's not just as simple as just selecting a window or window type. You have to look at the building as a whole. And so there are several ways of doing that, and finding a CEA or a passive house advisor should be able to help you with that. There is one more question. Have you had a sealed unit failures, and what kind of lifespan can we expect on the glass?
It's impossible to be a window manufacturer and not have had seal failures. Generally, seal failures for us tend to be, well, they're extremely uncommon. Most of the time, any sort of replacement of sealed units is typically due to physical damage or the potential for a manufacturing flaw. So maybe it was accidentally mishandled or something, and there's a smudge inside the glass. But in terms of seal failures, as I mentioned, that product that we've seen in use going back to the early 80s in our 2000 home, that there is a particular house that we actually replaced all of the sealed units recently. It was built in 1982, and all of the sealed units were still 100% functional. None of them had failed, but it was just clear glass. So they needed to do a replacement to take advantage of the low E coatings.
Was that cardinal glass, Mike? Had they used cardinal glass in the original windows?
Ooh,
Okay.
I doubt it.
Okay.
That was probably put together by a local manufacturer.
Okay.
So yeah, I mean, our glazing technologies have improved quite a bit, like the sealant technologies and everything like that. But the base concept that we use, where it's dry glazed, so that we're not relying on the structure of the glass to beef up the window, we're holding it inside of a structural frame and not allowing the environmental stresses to work on the window. That adds to the longevity of the unit and certainly bears out in practice.
That's a great answer. So Mama Bird has a couple of questions here. Do you do RAL colors for the windows? And also, can you speak to the 3 low E categories? So that's the 3 low E categories is kind of a continuation of this conversation about glass.
Yeah. So the colors that we do offer, obviously, they are European foils, so they will have a RAL number associated with them, but we have a standard range, and I believe it's a dozen colors. So we don't do custom colors. It can be done. Our windows are paintable, but it's not something that we're fans of as a manufacturer. We don't do painting in-house or anything like that. It's not the preferred finish. The 3 low E types, we use cardinal glass. So we basically, you can say there's basically a low, medium, and high gain options. And so the center of glass values for gain are going to be around 20%, 30%, or 55% approximately. So there will be some differences depending on, the thickness of the glass will affect it a little bit. And you may go with like a 6th surface coating. So you have 3 low E layers rather than 2. That's pretty infrequent, especially if you're not in very cold climates. But that sort of thing sometimes occurs, and that changes your options. But you're still essentially going with low, medium, and high. And you can't really dial it in specifically. You're kind of just, what's your strategy and which one do you want? And then we'll tell you the exact value that you're going to get out of your unit.
One more question from Sean. So he's asking whether, with the improvement in glazing tech, do you see a move towards quad glazing in extreme climates, or will triple glaze options fill the need going forward still? Good question.
It is a good question. The quad glazing, I find, is kind of an interesting one. I've picked up a window with quad glazing, not for long, and I wouldn't want to do it again. You obviously are increasing your cost. You're increasing your embodied carbon with the part of the window that has the heaviest embodied carbon element, the glass. There's a tremendous amount of energy involved in manufacturing glass and shipping it and everything like that. So drastically increasing your embodied energy may be interesting to see what the balance is in your building over the long term. You don't get the same improvements, jumping from double to triple glazing. You've got a highly diminished return going from triple to quadruple glazing. And the durability of the unit will usually substantially decrease because you have more seals and more movement within the window that causes stresses on the seal. So, the ability to apply a warranty or expect the long-term durability. Obviously, we don't have any particular experience with quad glazing as a manufacturer, so we wouldn't know what the lifespan would be, but I know that the manufacturers that we deal with have tested quadruple glazing and they've said it's not really something we're interested in getting into, just because they don't see that long-term durability out of it. So for a bunch of the complications and the extra weight and the handling and everything like that, once you put the window together, you start to see a diminishing return out of that quadruple glazing. Personally, I think that the realistic pathway forward is going to be more advanced technologies rather than more panes of glass being applied. So who knows what those technologies might be, whether that's, vacuum insulated glazing or, something of a nature where it's not something you have actually seen or just this incremental improvement. It's going to be something that's a different way of looking at glazing to improve the performance.
Just to add to that too, the installation can make a big difference. The way that it's installed and over insulation of the frames can make a big difference and bring a triple glazed window to the same performance or better than a quad glazed unit anyways too. So there are ways of doing that in really cold climates. And I think Sean has also said, I've only seen it in a few small specialty products and the extra complications make it sound less useful for sure. So, okay, I think that's the end of our questions. If everybody's happy, I have one question, Mike, for you. It's a question about the windows, the bigger window openings and their location in the high-rise buildings and the taller buildings. And the safety of the in-swing windows swinging in for more than 4 inches. Are there stops available to hold them at 4 inches? And I'm asking that question not only for the purposes of multifamily and tall buildings, but I've also had clients who were concerned about how far the windows come into a room, and a stop would be really nice.
Yeah, it's with some of the recent increases in code restrictions on windows, we're now finding single family residential homes are requiring limiters on the windows as well. So we have 4-inch restrictors that obviously conform to code. They're depending on the specific code limitations in the areas, and as well as the comfort level of the owners. If it's a single family home, there may be an allowance for an opening greater than 4 inches, but you still want some form of restriction on there. So there are ways to stop a window, not just at the 2 or 3 inches or the max 4, but it's usually a little less than 4. But we have restricted windows to other points, and similarly with doors, especially if you're dealing with like a Juliet door or something like that, then we can do different limitations. And one of the common things that happens with the windows is it's really that tilt for ventilation that you're using 99% of the time. Like very, very seldom do I open the windows in my house to the swing function.
Yep.
And so we can also set the hardware in a tilt before turn, so that when you turn the handle 90 degrees, you're tilting it. So it's the first function of the hardware. And that's what I used in my own home. I find it absurdly convenient And then you don't even have to worry about the swing, really. You've got a couple different ways that you can prevent the swing function at that point. So
That's great. I didn't know that. That's awesome.
yeah.
Okay. I think that's it. And there's a lot of thank yous, and thank you, Mike, for the presentation today. This has been recorded and it will be on the Passive House Alberta website sometime in the next few weeks. Thank you so much, everybody.
Awesome. Thanks for coming and listening to me talk at you.